Good morning, guys. कल हमने फुल कन्वर्टर के बारे में डिस्कस कर दिया, मतलब टू पल्स कन्वर्टर है। टू पल्स कन्वर्टर में 4 एसीआर्स होगा, राइट। चार एसीआर्स होगा। अभी और 4 डायोड के बारे में भी डिस्कस कर दिया हमने, अनकंट्रोल्ड रेक्टिफायर। नाउ सो मीनिंग 4 डायोड सेपरेटली डिस्कस कर दिया, 4 एसीआर्स 4 थायरिस्टर सेपरेटली डिस्कस कर दिया। 4 डायोड वाला अनकंट्रोल्ड है, 2 पल्स है। अभी 4 एसीआर वाला फुल कंट्रोल्ड है, ठीक है, 2 पल्स है। अभी हम डिस्कस करना सेमी कन्वर्टर है, मतलब इसमें 2 एसीआर 2 डायोड होगा, ओके, सिंगल फेज सेमी कन्वर्टर। और we can say here now semi converter are half controlled, full control नहीं है, half controlled. So what will happen here? We're discussing AC to DC converter, don't lose the context. Always we take a RL load or RLE load and assume that there is a high inductance. Assumption क्या है इधर? इधर नहीं, normally in all the converters we assume that L is very high. L is very high so that I naught is constant and continuous. I naught is constant and continuous. We are not changing the value. Rather, we say continuous. So RL. Now I told you 2 ACRs, 2 diodes. So I am giving AC supply. Okay. You can start operating this here. Initially, okay, maybe you can consider this as a 1 here now, so that easy to draw the waveforms 1 and 2. T1, D1, T2, D2. Okay, fine then. Let me draw the waveforms. So here also circuit turn off time निकालना and Vs and output voltage देखना पड़ेगा। और डिफरेंस क्या है फुल कंट्रोल्ड में, अनकंट्रोल्ड में, और ये वाला सेमी कन्वर्टर और हाफ कंट्रोल्ड में। So please identify the difference here. V0. डायोड के लिए गेट सिग्नल नहीं चाहिए, T1 के लिए गेट सिग्नल चाहिए. तो what will happen here now? I'm giving a alpha here. This is the gate signal. ये वाला alpha है. ये वाला नहीं तो even 1 is ready for the conduction. क्योंकि ये वाला प्लस है, माइनस है. तो ये फॉरवर्ड ब्लॉकिंग मोड में सिग्नल देना चाहिए कंडक्शन के लिए, लेकिन ये रेडी है, ये चालू हो गया. ये चालू हो गया क्योंकि अनकंट्रोल्ड है, माइनस कनेक्ट कर दिया कैथोड को. सो ये वाला शॉर्ट सर्क्यूट है. लेकिन इसका पार्टनर कौन है? कंडक्शन के लिए नीचे से एक डायोड, ऊपर से एक एससीआर. इधर नहीं, जो भी सर्क्यूट में देखो ऊपर से एक और नीचे से एक कॉम्बिनेशन में और लोड के साथ कंडक्शन में जाना चाहिए. लेकिन इधर क्या है, ऊपर वाला दोनों बंद है अभी. I'll tell you when it is get on. Assuming that T1 is not at on, D1 is not at on initially, then what will happen here now? In fact, at this period, T2 is on. How T2 is on, I'll tell you later. First, you please understand this initial point. This is the V0, and up to pi. When it is triggered, what will happen is when it's triggered, T1 D1 conduction में जाएगा. This is alpha to pi. Same ये वाला waveform. This waveform will come. I'm drawing that. So look at the difference here. Why it is not going to next pi plus alpha तक क्यों नहीं जा रही है? फुल कंट्रोल में pi plus alpha तक गया, इधर क्यों नहीं जा रहे? देखो, alpha to pi, T1 D1 is conducting, T1 D1 is on. Okay, next. So you know the conduction and the direction here now. I naught is already done. Then pi to omega t is next to pi to pi plus alpha. Who is conducting here now? T1 D1, and now when at pi, what is happening is this is minus a वाला plus. तो ये D1 बंद हो जाएगा, डेफिनेटली नेगेटिव आ गया ना, नेगेटिव आ गया. सो D1 पहले कंडक्शन में चल रहा था, ये बंद हो जाएगा. लेकिन T1 has still is conducting with what? With along with D2, क्योंकि D2 अगर ये वाला माइनस आया, सो D2 कंडक्शन में जाना चाहिए. ठीक है, so please understand this one. So T1 D2, now T1 D2 is on. So V0, ये दोनों शॉर्ट सर्किट हो गया. So इसका वोल्टेज 0 होगा, V0 का 0. So pi to next to alpha, pi plus alpha, where this is pi plus alpha. I hope you understand this point. ये वाला critical है, pi plus alpha. But who is conducting here now? इधर conduction कौन है? Who is conducting here? T1 D1. From here to here, who is conducting? T1 D2. D2 के लिए सिग्नल नहीं चाहिए. जब ये वाला वोल्टेज नेगेटिव आएगा, D2 तुरंत ऑन हो जाएगा, गेट सिग्नल का जरूरत नहीं. लेकिन T1 स्टिल कंटिन्यू, क्योंकि इंडक्टर है ना, इंडक्टर में करंट कंटिन्यूस होना चाहिए, इसलिए फोर्सफुली T1 D2 से साथ जाएगा. ठीक है. So next here, now we are giving the gate signal. We are giving the gate signal to T2. When you give the gate signal to T2, now this voltage will come. ये वाला voltage आएगा. So this is what I was drawing. So D2 is already conducting. Now since the T2 is triggered, the triggering is for T1, the triggering is for T2. T2 को आपने trigger कर दिया इधर. So T2 already conduction में था अभी. So T2 trigger कर दिया along with D2. Now conduction में जाएगा. Now this is what again T1 triggered alpha here now. So 2 pi plus alpha is nothing but 0 plus alpha. This is 2 pi plus alpha. So this is 2 pi plus alpha. So 2 pi, this is 2 pi. So here who is conducting? Same continue होना चाहिए. After 2 pi, D2 will off. So क्योंकि ये प्लस आ जाएगा, so ये बंद हो जाएगा. लेकिन इसके पहले कौन कंडक्शन में जा रहा था? T2. T2 should continue along with D1. That's what I was saying. T2 D1 ये वाला conduction. ठीक है? Again it starts moving on like this. Again this is T1 D1. Let me draw the current here now. Please understand the scenarios here. The problem with this semi-converter is both the diode are both one. I mean leg में ये वाला leg में single leg में दोनों switches है नहीं तो दोनों switches conduct कर रही है. This is dangerous. ठीक है, I'll come back to that. L is very high. इसका मतलब क्या है? I naught value कैसे होना चाहिए? I naught is a straight line, a constant magnitude. So to understand this, okay, 2 pi के बाद 2 pi to 2 pi plus alpha, I told you T2 D2. I want to draw the individual currents of thyristors. And of course, if you want to draw diode also you can draw. Thyristor का current कहाँ से कहाँ तक conduction में जा रहा है? IT1. Tell me now where is T1 is conducting? T1 कहाँ से कहाँ तक conduction में जा रहा है? Alpha to pi plus alpha. Alpha to pi plus alpha within a time period of pi. This is what? And then 2 pi, there is no 2 pi, and then 2 pi plus alpha. That's what I say. This is 2 pi plus alpha. So again, it's conducting 3 pi and so and so. Similarly, IT2 देखो इधर लिखा ना कहाँ से कहाँ तक. This is pi and this is 2 pi plus alpha. And 2 pi plus alpha. So it is conducting pi plus alpha to 2 pi plus alpha. And of course, इधर भी है alpha है ना. 0 to alpha is T2. But within a time period of 2 pi, only conduction period is pi only. Okay. So this is how, and the circuit turn-off time. And the circuit turn-off time is two things I mentioned already. Circuit turn-off time is omega Tc. Diode kaha se, within a time period of 2 pi, where the diode is kind of reverse biasing here now. You can see, you know, your SCR. You can see here now SCR. Look at this one. T1 मान लो. T1 का बारे में देख लो. Within time period 2 pi, 0 to alpha, is it reverse bias T1? 0 to alpha मतलब positive. T1 is forward blocking mode. Okay, that is not reverse biased here now. Let us see one by one. I'm talking about. You'll understand better. Talk about T1. Circuit turn off time के लिए need to see reverse bias time. RB reverse bias time for T1 or T2. T1 के लिए देखो. See, for T1 both will be same. T1 के लिए omega T 0 to alpha. What is the state? Omega T0 to alpha. Is it reverse biased? Which mode it is? SCR. T1 कौन सा mode में? T1 is in forward blocking mode. Gate signal नहीं दिया, reverse bias नहीं है. उसके बाद alpha 2 कहाँ तक? pi plus alpha कौन सा mode है? This is conduction. So what is left here now? 2 pi में क्या बचा है इधर? Omega T pi plus alpha 2 pi. Only in this period it is reverse biased. Only in this period it is reverse biased. So I want circuit turn off time का मतलब कौन सा टाइम पीरियड में ये वाला रिवर्स बायस है. डिफरेंस कितना है? ओमेगा TC which is equal to 2 pi minus pi plus alpha. That is the difference. So this will be pi minus alpha. Very important. There are gate questions. This is the circuit turn off time of this one. Right. You can mention this. The problem, as I mentioned here now, semi-converter का problem क्या है? Both the switches are short circuited. So that creates a short circuit on the source sometimes. So mention that point. So this is let alpha, pi plus alpha, and so on. Let alpha, pi plus alpha, and so on. There is a possibility of short circuit. There is a problem. There is a possibility of short circuit across the supply, when incoming thyristor conducts before outgoing thyristor stops conducting. Before outgoing thyristor stops conducting. Okay. So to avoid this, please mention to avoid this, a freewheeling diode should be connected. A freewheeling diode should be connected across the load. So what is the semi-converter में ये वाला? Tell me now. Okay, first V0 calculate करो. Average voltage. What is the time period? 1 by pi alpha to pi. So this is Vm by pi 1 plus cos alpha. Is it not same as a resistance? All semi-converter waveforms or output voltage waveform is equivalent to full converter resistance load. Can you please mention that point? Semi-converter output voltage waveform, semi-converter output voltage waveform is equivalent to full converter with the resistive load. Full converter with resistive load. Okay. So what is the conduction period of each thyristor here? Tell me now, what is the conduction period of each thyristor here? How much conduction angle in fact? कितना time period ये वाला conduction में गया वाला? Can you see here now? कितना time period IT1 conduction में, IT2 भी conduction में? Within a time period of 2 pi. What is the conduction angle of thyristor? Any thyristor within a period of 2 pi. How much? 2 pi में मैं ये पूछ रहा हूँ, 2 pi में कितना टाइम ये वाला कंडक्शन में है ये भी? Is it not pi? Is it not pi? Pi plus alpha, 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 2 pi plus alpha. Is it not pi? Hence, what is the average current of thyristor? ये वाला magnitude I naught है. So average current कितना होगा? Just I naught by 2, you can say. I naught into pi by 2 pi. I naught by 2. Average कितना यार? Just average calculate करना. RMS is I naught by root 2. Fine. So now our important thing is मैंने बता दिया ये वाला period में ये alpha और pi plus alpha, ठीक है? So you see here now this is short circuited. T1, T2 short circuited. T2, T1 short circuited here now. And if one of the thyristors, if one of the thyristor, or rather I would say incoming thyristor is on before the outgoing thyristor is off, in that case all 4 will be kind of short circuited, which makes the source to get short circuited. That is dangerous. So freewheeling diode should be connected. Let us see here now freewheeling diode with semi-converter. I'll show here only, don't worry. So I'll keep it this as such. So I am drawing this semi-conductor with FD. With FD means so when this FD comes into picture here now, I'm just drawing the your source. There is no change in the V0 waveform, but who is conducting here, that's a matter. So mono, this is alpha for T1, this is alpha for T2. जब वाला फॉरवर्ड बायस होगा तभी अल्फा देना चाहिए, otherwise no. We'll start from here to understand this. Alpha to pi, 2 pi, and 3 pi. This is pi plus alpha. I'll start from alpha only. So alpha trigger कर दिया, so T1 D1 conduction है. So this waveform will come. So I'm drawing that waveform. Alpha to pi. Pi to pi plus alpha. At pi plus, what will happen? This becomes minus and plus. ये वाला conduction में है ना already. इससे पहले इधर conduction में T1 D1 conduction में. This minus is connected to freewheeling diode. Immediately freewheeling diode comes into action. So freewheeling diode is current is going through the freewheeling diode. ये वाला करंट इधर जा रहा है तो ये बंद हो जाएगा. T1 D1 वैसे ही बंद हो गया क्योंकि माइनस इधर प्लस आ गए तो ये बंद होगा. T1 इससे पहले T1 D2 में कंडक्शन में जा रहा था. देखा पाई टू पाई प्लस अल्फा इन दोनों में कंडक्शन जा रहा है क्योंकि फ्रीव्हीलिंग डायोड नहीं है. सो T1 D2 इज एक्टिंग एज ए फ्रीव्हीलिंग एक्शन. अभी क्या हो गया, फ्रीव्हीलिंग डायोड सेपरेटली रखा तो इसमें करंट नहीं जाएगा. rather the current will go through freewheeling diode. So pi plus alpha तक FD action आएगा. So there is no problem of source side short circuiting. Then pi plus alpha to 2 pi, same thing. T2 D2 will starts conducting. This is T2 T2, same as this one. Only difference is wherever these two elements are conducting, short circuit period में pi to pi plus alpha, 2 pi to 2 pi plus alpha. So this is 2 pi plus alpha. So now this is FD is conducting. This is FD is conducting. That's all. So if you draw the T1, कितना period के लिए T1? This is important. Asked in exam, gate examination. IT1. So कहाँ से कहाँ तक T1 is conducted here within a 2 pi period. 2 pi period में IT1. Don't you agree that only within a period of alpha to pi? only alpha 2 pi. Remaining portions no. FDI, the T2I, the FDI. So within a time period of 2 pi, only alpha 2 pi means pi plus alpha is being conducted. Another important thing is freewheeling diode conduction. Very important this is FD, IFD. फ्रीव्हीलिंग डायोड कहां से कहां तक कंडक्शन में गया था? कैन यू टेल मी? कौन सा टाइम पीरियड में फ्रीव्हीलिंग डायोड चालू हुई? कौन सा टाइम पीरियड में फ्रीव्हीलिंग चालू हुई है? ये वाला इधर लिखा मैंने पाई टू नो पाई टू 2 पाई में कॉम्बिनेशन से ना, पाई टू पाई प्लस अल्फा एफडी, पाई प्लस अल्फा टू 2 पाई T2 D2. सो मतलब only pi to pi plus alpha is FD and 0 to alpha. So let me, I have written here. And so pi plus alpha to 2. So you can see it now. What is the time period actually? You have a time period pi I, evaluate time period pi. For a time period of pi, FD freewheeling diode is conducting for alpha. In this case, thyristor IT1 for a time period of 2 pi, thyristor IT1 का current फिर कब आएगा? IT1 का current 2 pi plus पे आएगा. This is the one. So इधर time period is 2 pi, इसके लिए इधर time period is pi, क्योंकि waveform IFD का waveform है ये. So pi is the time period. So pi में alpha conduction में जा रहे. ये वाला necessary है to calculate the average currents, average current of the thyristor, average current of freewheeling diode, average voltage, all these important. क्यों average important है? मतलब ये वाला AC to DC converter है ना, phase control rectifier है ना, so output we are interested in the DC terminologies. So वो calculate करना, let me do that. So आपको समझ में आ गया ना ये वाला? So difference क्या है समझ में आ गया ना? So I'm erasing this portion, not needed now. So freewheeling action में इससे पहले ये वाला ये दोनों freewheeling action चल रहा है, एक बार दूसरे बार ये दोनों चल रहे हैं, क्योंकि freewheeling डायोड नहीं है. अभी क्या आ गया? ये नहीं चल रहे, ये only cross conduct कर रहे हैं, T1 T1 T2 T2, not simultaneously, mutually exclusive. Now the freewheeling action is there. So this is we use most, this is the one actually we use. We have to do the Fourier analysis for this one. Okay, tell me the source current here. Very important one for me, the source current. I want to draw the source current waveform. This is the source current. Okay, 0 to alpha, I'll come back. What is happening? I'll start from the alpha to pi, pi plus alpha, pi plus alpha to 2 pi plus alpha. Okay, tell me now, 0 to alpha कौन conduction में जा रही है? Okay, no problem, you can tell this one. 0 to alpha, who is conducting? 0 to alpha, who is conducting? Look at the picture. 0 to alpha, who is conducting? इधर लिखा मैंने, इधर भी लिखा मैंने. Who is conducting? Freewheeling diode, excellent. So जब freewheeling diode में conduction जा रहा था through the load is continuous, I0 is continuous. Why the source will give the current? No current will come from the source. All are open, 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 open. only the current is going here. Now there is no connection to the source. अरे कनेक्शन को सोर्स नहीं तो फ्रीव्हीलिंग डायोड में करंट कैसे आ रहे? मैंने पहले बता दिया आपको, इंडक्टर is acting as a source and the inductor releases the energy here. Now that's the reason I told you inductance is a large value, very high value, such that it stores the energy and it releases the energy to the load. Our load is kind of a resistance and inductor. So इसलिए ये वाला पीरियड में 0 to alpha period में there is no source current. Now when you trigger the T1, now what will happen? T1 D1 conduction. Now the current will go this way. Freewheeling diode is off. T1 load, then D1 and source. So this is how the direction when T1 is triggered. So that's a positive current. क्योंकि whatever the direction I have represented, left to right direction है, इसी direction में जाएगा. क्योंकि numerator ऊपर वाला positive है. This is how it will go. Then pi 2 pi plus alpha. Who is conducting? Pi 2 pi plus alpha. कौन conduction में जा रहे हैं? Who is conducting to make our load continuous? Load current continuous. Pi 2 pi plus alpha. Who is conducting here? Pi 2 pi plus alpha. Can someone tell me? Pi 2 pi plus alpha. Look at here now. I have already written. Need not even worry about this. Pi 2 pi plus alpha. Who is? Pi 2 pi plus alpha मैंने लिखा है इधर. Who is conducting pi 2 pi plus alpha? It's a freewheeling diode. लिखा ना? So why attention? Then pi plus 2 2 pi. Pi plus 2 2 pi plus alpha to 2 pi. So this is minus plus. So T2 D2. T2 will on. Current will go this way to the load and will come to the D2 and back to the source. Opposite direction में जा रहे. I will show you again. Current will go this way. Will go to T2. Load में जाएगा. वापस आएगा and then D2 में जाएगा and source current opposite direction में जा रहे. Opposite direction. So negative current. So this is the source current here now. And semi-converter waveform is now this is the one. I have to take Fourier series for this waveform. Careful this one. इसको Fourier series में करना है. Full converter में Fourier series हमने कर दिया. So now I will have to do the Fourier series for this. Okay. Anyway, before that, let me conclude the semi-converter one. Average conduction period and those things. Let me write it here now. ये वाला semi-converter without freewheeling diode I'm erasing. इसका जरूरत नहीं. This is important for your exam. I'll write the conduction angle of each thyristor. First, you tell me what is that one in semi-converter. Conclusions I am writing here now. You are with the freewheeling diode only. Conduction angle of important evala. Conduction angle of thyristor for every 2 pi. Time period is 2 pi है ना, for every 2 pi. कितना इधर देखो बस. Please just look at our waveforms and tell me. This is pi minus alpha. So then average thyristor current. Average thyristor current is I naught into time period. Total current is I naught. How much period के लिए conduction है? Pi minus alpha. Total time period कितना है? 2 pi. Similarly, RMS thyristor current. I naught into under root of this one time period. Just a simple mathematics. Use the average value, RMS value. Now average, this is asked in GATE examination, average freewheeling diode current. Average freewheeling diode current. Freewheeling diode current time period कितना है? Pi है. Pi में कितना conduction में जा रहे हैं? Alpha period. So I naught into alpha period चालू है वाला within a time period of pi. Alpha by pi. Of course, RMS FD current I naught alpha by pi. And source current, yes, this is important. RMS of source current. Networks में पूछा हुआ, networks में ये वाला questions. Find the RMS value, average value. इसका waveform दिया मैंने, magnitude is I naught. ये वाला. So you can see here now. Within a time period of 2 pi, you can take, since it is RMS value, you can take 0 to pi also. क्योंकि positive and negative, square of it, it will go. You can take this period 0 to pi, then you can calculate also RMS value. So I naught में मतलब total pi में pi minus alpha period, alpha to pi में conduction में जा रहे हैं. So I can say here now I naught into under root pi minus alpha by pi. This is the value for this. Okay. And now मैंने बता दिया another important point इधर क्या है, मैंने source current का Fourier series करना चाहिए. So let me do that. We have done yesterday for the full converter. Now I need to do for the semi converter. First, you please copy this one. Bhaskar, you can off your video. Bhaskar. Bhaskar, your video is on. Bhaskar, can you hear me? Yeah, fine. So let us do this one, Fourier series analysis for the waveform which you are seeing. Source current का waveform है ना, yes, उसके लिए Fourier series करना चाहिए, ये वाला important है एग्जाम के लिए, ठीक है? Let us do that. I am clearing this one. I hope you have copied this. So only this waveform, source current, ये वाला waveform Fourier series करना चाहिए. Semi-converter IS. Just now we have drawn alpha to pi. So this is pi plus alpha and pi plus alpha to 2 pi. This is the waveform. And just that Fourier series, you have to do the Fourier series analysis. So IS value is, if you do the Fourier series analysis, see the लिख रहा हूं इसको, sigma n equal to 135 to infinite 4 I naught by n pi, okay, and cos n alpha by 2 and sine n omega t minus n alpha by 2. See, ये वाला, please try to remember these things. Only the source current equation. Full converter में याद रखना है and semi converter में याद रखना चाहिए, क्योंकि अगर ये वाला याद रख दिया तो fundamental current भी निकाल सकता है अपने, fundamental current IS, if somebody asked, right, which is 4 I naught by cos n alpha by 2 upon root 2 IS1, and even the total RMS current also you can find. And moreover, not only that, we can find the values of CDF, DF. Yesterday I have defined CDF, DF का values भी calculate कर सकते हैं. So by the way, what is the RMS current of fundamental one? This is IS1. RMS fundamental current. So means this is the one. So I'll make this, that is IM 4 I naught by pi cos, and n is 1 here now, cos alpha by 2, and this is 1 by root 2. Okay, 1 by root 2. Vm by root 2 है ना, Im by root 2 है ना, so that is a value. So it becomes 2 root 2 I naught by pi. Don't try to remember these things. Only remember this one. IS full converter, IS semi converter. So cos alpha by 2. It's nice. By the way, what is IS? RMS of source current. We already done. So that is I naught into, which has a period of pi plus alpha only, 1 by root 2. मतलब under root of this value, IS का value. Now CF DF मैंने define कर दिया. Very important, very very important. We'll see the gate problems anyway. And now I need to write the CDF. So CDF value, yesterday I have defined CDF, which is equal to IS1 by IS. So just IS1 I know, IS I know. You need to just substitute that one, no need to remember the values. So if you do that, I'll just write it and leave it. You can finish the calculation. Root 2 I naught by pi cos alpha by 2 upon I naught get cancelled anyway, under root of pi minus alpha by pi. This comes around 2 root 2 I naught get cancelled. So cos alpha by remaining same, cos alpha into 2. Then what will happen? 1 root pi, either root pi. So root pi bacha hai. So under root of pi, either be under root hai na, pi plus alpha. This is the first one. DF, displacement factor, current distortion factor and displacement factor. DF is cos theta 1. Theta 1 is cos, replace kar diya minus alpha by 2. So cos alpha by 2. Third one, THD, total harmonic distortion or harmonic factor, which is equal to 1 by CDF square minus 1. So we just need to find the value. The most important one is power factor. CDF into DF. DF पता है, CDF पता है. ये दोनों multiply करो, CDF and DF. You get this one. Okay, these are the important things in the semiconductor. And something we can have a power input also. Always the power input is fundamental power, real power, power input. भास्कर देख लो वीडियो ऑन हो रहा है आपका. VS IS1 cos theta 1. ठीक है, ये सब्स्टिट्यूट करना है. So if you just substitute all the values, IS1 I know, VS IS1 का वैल्यू है ये 2 root 2 I naught by pi cos alpha by 2 and theta 1 is cos alpha by 2. So this is cos square theta, right? We can convert into 1 minus 1 plus in this term, and finally we'll be obtaining the value is, so V naught I naught. V naught is average value. We have already done the average value calculations. V naught is average voltage, I naught is average current. That's a power input, real power input. The reactive power input also, we have one expression. I'm just writing here now, sixth one, reactive power input, Q. Mathematical formula क्या होता है? VS IS1 sin theta 1. So if you solve this one also same as what we do, you can see now one thing you can do, what you can do is VS IS1 common है ना, cos theta इधर है. So what I do is I'll divide with cos theta, multiply with cos theta. So what will happen here? VS IS cos theta we already obtained. So what we are remaining? VS IS cos theta we got the value as V naught I naught. What we left is tan theta. Tan theta, theta value is alpha by 2. So I can say tan alpha by 2. That is a Q. V naught I naught tan alpha by 2. Okay. This is about the semi converter. With this, the single phase things are over. Single phase, full converter, semi converter, uncontrolled one, all are kind of over. Three phase. Before going to the three phase, I would like to see some questions, gate questions. देखना चाहिए ताकि आपको कॉन्फिडेंस मिल जाएगा क्या चल रहा है, क्या वेव फॉर्म, सब कुछ पूरा सुबह से शाम तक वेव फॉर्म से चल रहे हैं. ऐसा नहीं कि मतलब बहुत सारा हमने सीख लिया तो अप्लाई करना पड़ेगा प्रॉब्लम्स में. So let us see here now, single phase के ऊपर gate questions करेंगे सीधा. We don't wait until the all are finished. Let us do that one. Is that okay, guys? So let us see that. Let us solve some gate questions here now. Two 2018 question. Look at this. Just now we had discussed waveform by the semi-converter from sinusoidal source. Is ka value. Voltage sin A. This is Is. Just now we have drawn. So alpha kitna hai idhar? What is alpha here? So I need to find the IS1 solution. See, please look at yourself. So tell me what you understand here now. RMS value fundamental component current. Green color draw कर दिया ना? उसको IS1 चाहिए है. What is IS1? For this, IS instant total waveform का expression चाहिए. IS instantaneous value just now we have done. So for that is sigma n equal to 1, 3, infinite. You remember that 4 I0 by n pi cos n alpha by 2 semi-converter है ना? So sin n omega t minus n alpha by 2. This is what I have written. Then what is IS1? 4 I0 by pi 1 by root 2. Okay. Cos alpha by t is the value. By the way, what is alpha? It is given. Waveform is starting here now. Alpha equal to 30. So please substitute that. 4 I0 is 20 pi. This is 3.14. 1 by root 2 cos of 30 by 2. Get me this value. Latest question. Waiting. What is the answer? Have you done? नहीं कर रहे, कैल्सी रख दो ना पास में. Yeah, that's correct. It's 17.39. Excellent, Anjal. So let me write it that. Okay. Next question. Same 18 question. Eh? Most of the questions are single phase. Single phase full converter. Just drawing that, nothing else. Full converter में 4 SCRs होगा. And I have a load. So connected the source. And both are same. You take out separately or you connect this way. Both are same, connecting the sources. This is load. Across this one V0 and this is I0. Anti-parallel diode, मतलब freewheeling diode. One freewheeling diode is connected. Now tell me, हमने इतना सारा waveform stock कर दिया, तो which of the following are true here now? Yeah. So just see here now. This is average voltage. Or V0. Freewheeling diode. When freewheeling diode is kept, do you think the current voltage will go negative? Have you seen anywhere going negative? फ्रीव्हीलिंग डायोड रखा तो वोल्टेज ऑलवेज पॉजिटिव है, ठीक है, वोल्टेज ऑलवेज पॉजिटिव फ्रीव्हीलिंग रखा तो. And I naught, have you seen anywhere that our I naught is going negative with the freewheeling diode, without freewheeling diode, with R load, with RL load, with RE load, any load that you take it, I naught have you seen any time going negative here now? Even in the inverter mode operation, I naught is positive there, but V naught is becoming negative there. But level of freewheeling diode is kept. Which one is the correct? कौन सा वाला correct है इधर? Guys, tell me now, is it V naught positive or negative? First thing, always positive होगा, negative होगा. V naught is positive and I naught is always positive. This is our answer. I naught will never go negative. Voltage will never be negative. Freewheeling diode रखा. अगर freewheeling diode नहीं तो, so अगर freewheeling diode नहीं तो, yes, be positive. So that's correct. अगर freewheeling diode नहीं तो, yes, there is a chance that V naught can go negative. Instantaneous voltage can go negative. Even the average voltage also can be negative here. लेकिन freewheeling diode रखा ना तो कभी नहीं जाएगा. Fine. Another one. 2017 question. Input power factor of this network. Input power factor, normally what we do, there are two definitions. One is, if you know the source current waveform, input power factor CF and DF, but we don't know. They are a sine waveform. So we cannot find that way. Input power factor equals CDF and DF. So another mention, I have mentioned, if you remember, output power by input power, output voltage, that is V naught R, I naught R, okay, and Vs, Is. So output power upon input power. So diode में क्या होगा? Positive में direction में. Look at this one, waveforms. This is Vs. And this I naught क्या होगा? When it is positive, it gets conducting. Diode है ना? 0 to pi. Then pi to 2 pi, there is no conduction. Again pi to 2 pi to 3 pi. So means here now I naught R and Is. This is Is in fact. Source current is source current and I naught. Both are same here now. When I naught is there, then only source current आएगा. So I would say here now I naught R and Is are same. You are remaining with output RMS voltage and source voltage. Output RMS voltage कितना है? This is the one. I naught is given. V naught also same, right? V naught also same. 0 to pi. 2 pi में नहीं होगा. Then, so what is the RMS value? We know this is standard one. Otherwise, you can calculate V naught R, which is equal to 1 by time period. Time period is 2 pi integral 0 to t Vm sin omega t whole square d omega t. This is Vm by 2 standard one, we have done it. And Vs is the average value, RMS value. This is Vm by root 2. So what is the value here now? Vm by 2, Vm by root 2. This is 1 by root 2, which is 0.7079. I have given this definition, if you remember, when you're doing a converters. Fine then. Next question. It is 0.07 or 0.707. I think 0.707, right? So 1 by root 2, right? Yeah. So next question. So the question that is asked here, Evala semi-converter, right? Definitely a semi-converter. And the question that is asked is resistance loaded. Load is R. So RMS value of current, RMS value of current through diode D3. See this one, what is this one? RMS value of current, resistive load here. ये तो freewheeling diode है. So do you think that freewheeling diode will come into picture when resistive load is there? Just see our notes. Freewheeling diode, ये वाला action कब आएगा? पहला थिंग क्या है, अगर सेमी कन्वर्टर है फ्रीव्हीलिंग डायोड की जरूरत भी नहीं, अगर फिर भी रखा तो फ्रीव्हीलिंग डायोड में आर लोड में तो ये कभी नहीं जाएगा करंट. Just 1 second. So what is the value then? Yes, so that's correct. It's 0. No, so you please mention that. So value is 0. Mention that for resistance load, freewheeling diode will not come into action. For resistance load, freewheeling diode will not come into action either in full converter, either in, or in semi converter. Let it be single phase, let it be three phase. If the load is resistive or for resistive load, freewheeling diode will not come into action. Freewheeling diode will not come into action. Okay. For full converter or semi converter. Okay. Another question. Answer is 0 for this. Question. Lee's inductance is large enough to make load current continuous. What is this here now? Question is real power feedback to source is real power fed back to source means what is happening? It's a regenerative braking. I told you already what we need to do. Total value is V naught. The current is going is I naught here now. Okay. So solution real power fed back means what we want is V naught, which is equal to V naught and I naught. Total V naught है ना, V naught into I naught चाहिए. What is V naught here now? For full wave converter, we have already seen V naught. Do you remember? V naught equal to 2Vm by pi cos alpha. I asked you to remember also this one. So now 2Vm. Vm is 200 pi upon pi cos alpha. Alpha is 120. It's an inverter operation. Negative आएगा. Pi get cancels out. 400 cos 120. So cos 180 minus 60 cos sin 31 by 2. 2 to get cancelled. So this is minus 200 volts magnitude. So but we know that आ गया I naught कैसे निकालेंगे? To find I naught. KVL डालो. Yeah, until that's correct. Minus 200. Nice. So this is I know the expression V naught, which is equal to E plus I naught R. This is for converter. But what I told you is V naught, which is equal to minus E. You remember that? I naught R. This is for inverter operation. That is alpha greater than 90. I hope you remember this point. We have solved a problem also. So now V naught ka value this is, yes, you have to take as such, minus 200 minus E kitna hai, 800 minus 800, I naught R value is 20. So it becomes I naught value. Agar वाले this side goes 600 by 20, which is 30 amps. So we find this P naught value, power fed back. V naught is 200, magnitude. Yes, perfect summary. And until good. P naught ka value. Minus sign represents is going back. Kali magnitude calculate karo, काफी है. You can just calculate the magnitude. ठीक है. So yeah, that's correct. 200 into 30, it is 6 kilowatt. This is your answer. Yeah, that's correct. Anjay, say 6 kilowatt. next one. So you got the feel, right? How the questions will be, how the gate questions will be. I think you got the feel. We are doing AC to DC converter gate questions. And most of the things are single phase. Yes, there are questions on three phase, maybe questions, but we have done single phase, right? Look at this another question. Read the problem. क्या करना? Tell me the procedure first. क्या दिया है and what we need to do. करना है क्या? सिंगल फेज फुल कन्वर्टर सोर्स करंट का वेवफॉर्म निकालना पड़ेगा. सोर्स करंट का वेवफॉर्म मैंने दिया. अगेन 4I0 by n pi is देखो फुल कन्वर्टर में उसका मैग्नीट्यूड क्या है? I given to you. I told you to remember also. So then CDF and DF, you have to calculate that. Remember, I have given the power factor directly. This is IS, which is magnitude common. This is what the value we got it. And IS1 basically PF चाहिए. See, every time need not do here. I have derived and final expression भी दिया आपको single phase के लिए, like 0.9 cos alpha करके. You remember that 0.9 cos alpha I have given? Just for understanding, I am giving here. Just to show that previous problem 18 में 2018 में सेमी कन्वर्टर के ऊपर प्रॉब्लम आया पावर फैक्टर. अभी 2016 में फुल कन्वर्टर के ऊपर प्रॉब्लम आया. And IS is continuous, RMS value is I0. So then CDF is IS1 by IS. Substitute कर दिया तो 0.9 आएगा. DF is cos alpha. So this is 0.9 cos alpha. That's all. 0.9 cos 30. How much is this value? What is the answer? Yeah, Anshul, that's correct. 0.77. Yeah, that's correct, sir. Good. Okay, last problem. For the day, you solve yourself. Simple question only, and colored graphs are given. What I observed is for the first class and the maybe the classes now we're going, I see the difference in you people. Meaning the way responding and the way you are understanding the things. I think the way you are responsible for it. I don't know if you observe it or not. Do you really feel more responsible? Yeah, I feel that. Yeah, correct, Sahu. Yeah, that's my observation. And I see that you're learning also, right? Do you agree with me? I feel you're learning the things. Yes, correct. So look at the solution. हाफ कंट्रोल है सेमी कन्वर्टर में, हाफ कंट्रोल मतलब सेमी कन्वर्टर में RL load है, load is continuous, fraction of cycle the freewheeling diode conducts. I have given conduction period of a freewheeling diode. Options दिया है, just you can see and let me know. And see our waveforms, semi converter with freewheeling diode. I have given. fraction of cycle that freewheeling diode conducts. Look at that waveform. You got the feel what I'm discussing. This is where semi-converter, just now we told you. Semi-converter मतलब दो SCRs, दो डायोड मेन वाला और तीसरा फ्रीव्हीलिंग डायोड भी होता है. If you keep it T1, T2, T1, D2, now the freewheeling diode. When the freewheeling diode conducts, if you remember, freewheeling diode IFD, this conducts between 0 to alpha. Look at the waveforms. 0 to alpha here now conducts in this direction IFT to make the I naught continuous. And then pi here now. Then pi to pi plus alpha. And goes on 2 pi plus alpha. Within a time period, that's what they're saying. Within a period of pi, fraction of time. Within a period of pi, how much it's conducting? Look at our notes. This is what I have drawn. Only 0 to alpha. So this is alpha. That's what I was saying here now. Conduction, I have given this is conduction of angle of FD is alpha with the time period. The time period is pi. So the fraction becomes what? Alpha by pi. If you ask average value, IFT pucha the average value. This is I naught into alpha by pi. But they ask the fraction. So your answer is this. This is the average FD current. Right. This is biggest here. Okay, then if you copied, that's all I have now. So tomorrow we'll start the three-phase. Three-phase, you have to be very careful, very careful. थोड़ा ध्यान से सुन लेना, ठीक है? I'll make it simple. Don't worry. I'll make it too simple to understand. We'll continue tomorrow then. And evening machines will start synchronous machine. Okay. Okay. Thank you guys. Thanks. Thank you, Anchal. Thank you, Sahu.